So on the problems today, we aren't going to emphasize or focus on the solving process, because I hope by now you can take a derivative and set it equal to 0 and all that kind of stuff if I gave you a couple minutes to do it. So what we're going to focus on here is the new part of the process, which is the setups, because that's the hard part of the problem. So that's what we're going to emphasize. That's what we're going to focus on. So let's start with this one and read through it and see if you can pick out what we are trying to maximize or minimize. That's always what you want to start with on these problems. We're looking to maximize something or minimize something. Hopefully that should be an obvious answer, and slightly less obvious, what are we trying to maximize or minimize? And just so we have a naming convention here, I'm going to call this distance here x, and I'm going to call the vertical distance along here, I'm going to call it y. Okay. So hopefully, you know that we're looking to minimize. It's in italics and everything. And the slightly trickier question, if we want to minimize the amount of paper. So what quantity is going to help us measure amount of paper?
Area.
It's going to be area. The amount of space that we're taking up on the paper, that's area. So area is the thing we're looking to minimize. Okay, so we have two different areas. One of them is fixed, it's locked into place, and one of them can vary. All right, one of them can vary depending on what we use. So the one that is fixed into place, is our 24 square inches of print. So that is a constraint and is the formula that I'm going to use to get one of the variables by itself in terms of the other. So 24 is the amount of area of print of actual text that's on the page. So how would I find that area? Length times width. So in this case, x times y. X times y is 24. So let's go ahead and solve for y in terms of x. There we go. Now, the actual area formula that we're looking to maximize or minimize is the area of the entire page. So I'm going to do it as base times height, because that's what I always do for a rectangle here. So base times height. So our base is based in our horizontal distance here. So let's count our distance along. We have 1 inch margin plus our amount of text, our horizontal distance along the text. And is that our entire distance? No, we need to add the other margin, which is 1. So our base is going to be x plus 2. Same thing for our height. To get our height, we have our margins, which is the 1.5 along the top, and then we have our y distance, and then we have our 1.5 along the bottom. So that's going to be y plus 3. So our base times our height, that's going to be x plus 2. times our y plus 3, which I'm going to rewrite with one variable. X plus 2 times, well, what was y in terms of x? It's 24 over x. All right. After some calculus, we find that our minimum occurs. Again, we want to ignore negative numbers in our domain. So we're going to use x equaling positive 4. Should have gotten plus or minus 4, but not including the negative. And you can verify that that is indeed a minimum, which means that y in terms of x was 24 over whatever x is. So our y is 6. So using that, our actual dimensions the base along our distance here, well, we have that 4 plus the margins being 6. And then our height is our distance of 6 plus our margins will give us our total dimensions. So those are the dimensions that will give us the smallest amount of paper possible to work with how much text we need on the page. This next one I'm also not going to solve the whole way. We're mostly going to focus on the setup. So a soda can is to hold 12 fluid ounces. Find the dimensions that will minimize the amount of material used in its constructions. Again, we're trying to minimize. If we're trying to minimize the amount of material used in constructing a can, what are we looking to minimize? Is the amount of material used on a three-dimensional solid? Because remember, volume is the amount of space it takes up. It's surface area that you're trying to minimize here. And at this point, I will point out that if you are in need of a formula, of these kind of formulas in a problem like this, they will likely give it to you. It just depends on the problem. This is a cylinder. I would say like area of a rectangle, it just depends on what the formula is. Area of a rectangle, you should probably know it. Pythagorean theorem, you should probably know it. Volume of a cylinder, they're probably going to give it to you. If it's a surface area volume formula, they will probably give you the surface area or volume formula. So that's something to keep in mind on these problems. And surface area of a cylinder is twice the area of the base plus our circumference of the base times our height. There we go. Now, what is our constraint? Our constraint is that it holds 12 fluid ounces. If it holds 12 fluid ounces, how much the can can hold is what? That's the volume. How much space it takes up, how much it can hold, how much liquid it can hold, that's a volume question. So that we're going to use volume. So volume formula is going to be area of the base times the height for any prism, and a cylinder is prism-ish. So it's area of the base times the height. So that is pi r squared times our height equals, and we're going to convert this to cubic inches. And that converts to a big long decimal. And again, this is what we're going to use to write one of the variables in terms of the other. So this is our constraint that we have, that the volume has to be this. Surface area is the formula that we are looking to maximize or minimize. So we're going to solve the volume formula in terms of one variable, and then we're going to take that and plug that into the surface area formula. That's the flow of how these problems go. You're going to have the equation you're trying to maximize or minimize, and then you're going to have another equation over here that you're going to solve for in one variable so that you can plug it into the other. So in this case, I'm going to go ahead and solve for h so that I only have to plug it into one place. So to get h by itself, plus it's easier to get h by itself than it is to get r by itself in that equation. So to get h by itself, I just need to divide by pi r squared. So h is that big long decimal divided by pi r squared. So within my surface area formula, I would then go on to go 2 pi r squared plus 2 pi r h, and h in this problem I have solved for in terms of r. And this is where I'll point out that on a lot of these problems, in fact, I would say on most of these problems, you're going to get a calculator. The test on this chapter will be calculator allowed. Now, we have solved for a lot of these by hand, but keep in mind that you're going to get a calculator. So I will the only thing I'll say at this point is that from here, let's see, if I were to try and simplify some of this by hand, what I would do is I would take a 2 out of the whole thing, because both of these terms have a 2 on them. Pi cancels here. One of the r's cancels with here, and I would get, that would be pi r squared, and then one of the r's canceled here, so we have pi r, and then we have the 21.65628 over r. And then I'm going to stop the problem there, because then the actual taking the derivative process, actually let's do the derivative by hand. So I'm going to keep a 2 out in front. And then this would be a 2 pi r, right? Derivative of pi r squared. And then this is r to the what? Negative first. So I'm going to go minus 21.65628 over r squared, so that it's negative thing r to the negative second. And then I want to know when this guy is 0. And from there, I won't go through the rest of it because it's calculator time. You would want to find where that's 0. and then determine when it changes from negative to positive, and then use that value for r to get my height. And most of the rest of the problem is going to be done on the calculator once you get to that part of the problem. So if you get some really complicated formula, once you take the derivative and set it equal to 0, feel free to use the calculator as long as it tells you to use the calculator. You'll see, hopefully you know the book system of highlighting specific problems that are non-calculator and some problems that are calculator.